Good morning. Today I'm going to take the class about PCB design using EDA software. So it's a very good software for designing a PCB layout. If we know the circuit, we can easily understand what is the PCB and how we are going to frame the PCB designing. So I will show the layout and how to do this. Just a minute. So I'm going to type the website EDA, ECEDA, ECEDA, and in this we are having a two modes are there. One is nothing but a simulating mode, and next one is a software mode. That is a standard mode, simulation mode, and the standard mode. I'm going to pick a design online. In that standard edition, I'm going to click it because there only we are having a simulation mode. So if I need to change a standard mode to simulation mode, I will click this. And now the display is running in the front of a standard mode. Standard mode to simulation mode. So in that I'm going to click on new for that is a titles. So here new project. So I will write maybe simple LED LED design. Okay. So this is a create new project. I give the title as simple LED design, or you can give a LED design. Okay, save it. And after saving it, we are getting a layout like this. Okay, what happened? I need a component. We are having that library. So yeah, this is the main picture of what main layout of ECEDA. Here we are having a two things. Here you just noted here. It is a simulation mode. If I need to change it in a standard mode, I will simply click it, confirm, and now it is change it into standard mode. Okay, but right now I need a simulation mode, so I will be there only a simulation mode. In the simulation mode, what I will do, I will pick a supply. So there are two libraries. Normally, will go for a spice library. If I know, if I need a voltage source, I will get it through a library also. So voltage source. So that's what voltage sources. So it is like this: polarity, positive and negative. So I am going to place it in a layout. This is nothing but our PCB layout. There's a designing platform, ECEDA simulation platforms of Windows. If I need to zoom it, that is also possible through zooming. We are getting it 100%. Okay, so now the screen level is zoomed into 100%. So this is the source. And now what happened? I need another tools like that is what are the things we need. We'll just pick it there. So a resistor. I need a resistor. Need a resistor. So what I will do, I will click it here, resistor. So this is a resistor part. I need a resistor like this. So a number of resistors are there. I'll just click it a resistor of 1K and place it here. And I need a transistor circuit for this. So again, I will go to the transistor side, or otherwise you can simply put it in a common library also here. A transistor. Transistor is there. See here. The transistor we can get it from this layout. So this is the NPN transistor. I can able to fetch the components and place it in a layout. So this is nothing but a resistor, and this is the voltage source, and this is our resistance. So there's a transistor. Okay. So now what happened? I need a LED for this layout. So I put it here, and I need a ground also. Okay, so ground terminals. We can fetch the details here. If you put different grounds or there, so I will fetch the ground like this and put it here. So now what I will do, I'm going to connect. Actually, I need to rotate my LED is also possible actually. So what I will do, I will turn the position, and this is our transistor, and this is the what our resistors, and I need a capacitance also. Okay, so for charging and discharging the transistor, I need a capacitance. I will put it here, and I'm going to give the connections right now. Okay, and I'm going to give the connections right now through the there's a current limiting resistor. I'm going to give the connection. This is the wiring tools. This wiring tools, we are having the wired network, so I'm going to give the that is a connection. And again here also I need through this transistor resistance is connected through the transistor base network, and again I needed to connect to this capacitance also. I will connect here, and again I'm going to connect the part like this, the source which is connected to here. Okay, and again this is connected. This is the emitter network of a transistor. Transistor is there, so I'm going to connect. So this is the connection channels, and again I'm going to connect here. And now this connector terminal, I'm going to connect to the LED for basic operations of switching, and I'm connecting here. And I'm going to connect to this anode and cathode part. Actually, this anode is connected to the transistor side, and the cathode is connected to the ground terminals. And this ground is connected here. This ground is connected here. Okay, simply I connect all this network. Suppose I need to change the resistor value. Uh, Select this component, and the right side panel we are getting the prefix. I suppose I need to connect, change the prefix also. That is also possible. Resistance. I'm going to change this resistance, and I need to convert into 100K. That is also possible. 100K, but I need only a 1K. Okay, 1K is a nominal value, and this is a capacitance. Similarly, I'm connecting the capacitance. So I change the tag in the name of capacitance, and now it is in the that is a 470 or a 450 microfarad. A microfarad is there. Okay, so 450 microfarad. I placed here. I placed here. Okay, so I converted. Or we can we have a point on microfarad. If suppose I need to convert in terms of 1 microfarad, that is also enough for us. And now I'm going to check whether it is working or not. Now it is working or not. Okay, now there is no problem. It is properly fetched. Okay, because if there is any problem occurrence, it is not going to be displayed. So now what we do, we can convert this in terms of a PCB layout actually. So now I am going to convert in terms of a standard mode. Before that I save this, and now change into standard mode. So this is the standard mode, and now each part to be that is we are having a PCB layout. Actually, our motto is to convert the schematic in terms of a PCB layout. And now this is in the standard mode. Now it was converted from simulation to the standard mode. If suppose I am going to convert this in terms of a PCB, if it is not to be have a footprints, it is showing like this. So I need to map with the footprint. So I am going to select these things. Okay, so click this, and footprint is here. Footprint is here. Display footprint, and select a footprint. Suppose that is also there actually. The voltage source. I will simply put it in a voltage source. So open voltage source here. It is mapping with the key points or two terminals or that. So it is going to map with that. This mapping with your voltage source. Okay, so this is the voltage source. Just put it here. Whatever the voltage source we need, we'll connect. Okay, so this is the voltage source. Another sources. VLTAGESOU source. CE voltage source is there. Voltage source, and if I need a user contribution is also there. I can get it from here also. Okay, two terminals are there. So I am going to update the footprints, and now LED. I am going to give the okay LED for LED. Open. There's a OLED is also there. LED normal is there, and we are having a different LEDs. So we supposed to know what is the LED that we are going to use that. Okay, I am having the two polarities, so I need to connect like this also, and this terminal also simple. Simple that is a LED. I am going to use that. Okay, you can use if you know earlier. You can use this LEDs. See here, I connect this LEDs here, and now update everything. Update footprint is over, and now just convert. If it is not to be assigned with footprint, is not to be converted. So again, there is one more thing is there, a transistor that is also to be mapped. Transistor. We need a transistor, NPN transistor. Okay, NPN transistor. So for NPN transistor, this is the NPN transistor. Okay, I will use like this for NPN transistor. I will use like this. Update footprint. And now what happened? And now everything is that is assigned with the proper footprint. There's save it, Control S, and now convert to PCB. Now it is converted. So now what happened? All your devices are converted in terms of a PCB layout. Our aim is to build in terms of a PCB layout, sketch your layout. And now, if you want, you just otherwise you can put it here like this. So this is our transistor, and this is our voltage, and the resistor network. And through the resistance, we connected a transistor, and this is your capacitances. And now this is the LED. LED is here. LED is here. And now the layout is like this. Okay. So we have a voltage source, resistance here, a PCB layout, and this is the LED capacitances. Now I need to convert in terms of 3D or a 3D waveform. I need to use in the 3D waveform. That is also possible. So this is the 3D waveform or layout of our PCB design. The design is like this, and this is a transistor and resistance, capacitance, whatever we put in a simulation pack or standard pack. We converted in terms of a 3D view through the PCB design. We are getting it. So, what are the advantages of using the PCB layout using EDA is nothing but it's a electronic design automation. Is having all the libraries. If you know the circuit, we can simply convert it in terms of a PCB layout before what is before going to the real time application. This is one of the best advantages of using you see EDA software. Okay, so thank you for watching. If you are having any doubts, you can contact me.